I want to talk very, very quickly, I hope, about alternating current versus direct current. Okay? The idea is simple. Direct current is what we've been talking about so far. A battery, the resistor, or a capacitor, anything else, let's just stick with that, produces what's called direct current. Current runs in one direction in one of these circuits. Okay? Now, if I have capacitors in here and I let things kind of slosh back and forth, I can actually get a little bit of oscillation sometimes, but we're not going to really run into that. It's still really a direct current circuit. Okay? There is something called an alternating current circuit. We're going to meet a lot more of this later. Okay? In this case, the current goes back and forth. It actually just sloshes. All the electrons go this way for a fraction of a second, and they go this way for a fraction of a second. Back and forth, back and forth, and back and forth, and back and forth. Okay? Why would you do something like that? Well, it turns out it's easier to transmit or produce as well, but mainly transmit alternating current. It's a little subtle. We'll really see what's going on in about 3 weeks, but it's easier to make the voltage get higher and lower, it turns out, with alternating current. Okay, direct current actually has a lower resistance or lower power loss for transmission, but it's not easy to get the voltage up high for a high voltage line, it turns out. So we don't do it as much, at least on the full scale. So for instance, it's alternating current you get out of your wall. Batteries, however, since they're chemical in the way they work, actually produce direct current. Okay, so just want to show you one other interesting thing about these. If I did a graph of time and the voltage, direct current would be this. Okay? It's always at whatever voltage it's at. Okay? Battery produces 6 volts, 1.5 volts, 9 volts, whatever it does, but it sticks with that. Alternating current, on the other hand, cycles. Okay? So it goes up, it goes down to minus V, and then back up to V, and down to minus V, and back and forth and back and forth. An American wall current, that happens 60 times a second. That is at 60 hertz. Okay? In Europe, there we go. That happens at 50 hertz. By the way, if you ever wondered, that's part of the reason that it's really hard to move things back and forth in the US, in Europe. They also use a different voltage. This is a really interesting phenomenon, though, okay? And it has a lot of interesting implications for electronics, for example. The reason you have an adapter on your power supply when you plug your laptop in, that little boxy thing, is it's turning the power into direct current from alternating current. It's called a rectifier. Your electronics need current going in specific directions, and they can't have it sloshing back and forth, I wouldn't say randomly, but cyclically. Okay? So a lot of things care. On the other hand, a lot of things don't care. Your light bulb or your electric oven, if you have one, don't care. The current going back and forth really has basically the same overall effect with a certain amount of specialized time averaging thought about a little bit about it as direct current would. Okay? So your light bulb doesn't care. But a lot of components do care, so you have to be careful about this. We're going to deal more with this in, like I said, several weeks when we're able to talk about transformers. It's one of my favorite classes of the semester, actually. So I'm just putting this out there for you right now, and like I said, save it for later, but just be kind of aware of it for now. Bye, everyone.